Hello, I'm Bob. Today let's do the exercise for Chapter 10, Nonlinear Regression Methods. The Poisson regression model specifies the count y to have a conditional mean of the exponential form. We use Poisson function in this chapter. The maximum likelihood estimators maximize the log likelihood function. For Poisson regression, the maximum likelihood estimator is obtained by using the Poisson command. First, we use the cd command to go to the folder we would like to store the files. Then we use log command to record everything in a text file. In first question, we use Poisson command, nonlinear least squares command, and generalized linear model commands to fit the Poisson regression model. First, we use the dataset, which could be downloaded online, and keep those observations used in the textbook. We type Poisson followed by the dependent variable and the expenditure variables. We store the result using estimates store command. Then we regress the model using the option robust. Then we use the nonlinear least squares command to fit the model again, and store the results for using the default standard errors and the robust standard errors. The function form is the exponential form, and the option VCE, the variance-covariance matrix of estimators, specifies the robust option of the standard errors. Finally, we use the generalized linear model command to fit the model. The option family specifies the distribution of dependent variable, and the option length specifies the length function. Here is Poisson and log, respectively. We use the command estimates table to compare the results of the above 6 specifications. We use the option SE to tell Stata to report standard errors. The option B specifies how to format coefficients. We also tell Stata to show the model's titles. The GLM command gives exactly the same results as the Poisson command, and robust standard errors are higher than the default standard errors. The NLS command gives a little bit smaller estimates for the coefficients. In the second question, we use the medical expenditure dataset. We type describe to take a look at the information of the variables. We use summarize to obtain the mean, standard deviation, and other information of the variable. First, we generate a new variable, which is the total expenditure divided by 1000. Next, we use the Poisson command to fit the model and store the result. We do this for both default standard errors and robust standard errors. Then we use the nonlinear least squares command NL to fit the model. There is a shorter equivalent expression for the conditional mean function. Finally, we use the estimates table to compare the results. In question 3, we use different options for the standard errors. The most commonly used options are the default, the robust, and the cluster standard errors. The bootstrap standard errors are very similar to the robust standard errors. The cluster robust standard errors are a little bit higher than the robust standard errors. The fourth question is about predictions. After running the Poisson model, there are two ways to obtain the sample average prediction of doctor visits. The first way is to use the predict command and then summarize the predicted values. The mean of the predicted values is 3.957. Another way is to use the command margins. It not only gives us the average prediction of doctor visits, but it also has the confidence intervals and the p-value. For the male sample, the average prediction of doctor visits is 2.76. The average prediction of doctor visits for someone who is privately insured, has a chronic condition, and has an income of 20,000 is quite high. It's 7.88. Question 5 is about the marginal effects. The finite difference method is for the categorical variables. We use the I operator before those categorical variables and run the Poisson model. After that, we use margins command to obtain the marginal effects. We can also use the calculus method for those categorical variables. This time, we run the Poisson model without using the operators, and then also use the margins to obtain the marginal effects. The marginal effects using these two different ways are not exactly the same. Finally, we use the margins command with the add option to obtain the marginal effect evaluated at a particular value of the regressors. For someone who is privately insured, has a chronic condition, and has an income of 20,000, his marginal effects are higher than the average marginal effects. Question 6 shows that the pseudo R-square is not necessarily a good measure. We generate a simulated dataset. The pseudo R-square is negative, which does not make sense. The correct R-square could be calculated using the model sum of squares divided by the total sum of squares. In the last question, question 7, we compare two models using information criterion or likelihood ratio test. We run a full model and another model with income excluded. So the second model is nested in the first model. Smaller information criterion are preferred. So the first model with income included is better. The likelihood ratio test shows the p-value is equal to 0. So we reject the null hypothesis of 0 coefficient for the income variable. So we can conclude that the full model with income as its expenditure variable is an appropriate model. Thank you very much for watching this video. Goodbye.